Right, so the next question we're going to look at is question 13 on page 302. A tree 32 meters high casts a shadow 63 meters long. Okay, so there's our shadow. Calculate the angle of elevation to the sun. Okay, so elevation is the angle from the horizontal looking up. Give your answer in degrees. Okay, so it tells us in the question that the tree is 32 meters high. It doesn't show you that in the diagram, so it's important that you draw that in. So always see, is what is given to you in the question actually shown in the diagram? And if not, write it in. Okay, so we're looking for this angle here. Now, we know that this is a right angle because the tree will grow up perpendicular here, so that's going to be a right angle. Okay, straight away you write down your the trigonometric ratios. So we know the word SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so we label our sides. This is the angle we're looking for. We know this is the hypotenuse, but we don't have it. This is opposite because it's opposite the angle we're given, or we're looking for, I should say, and this is the adjacent. So which one of those formulas, or sine, cos, or tan, uses opposite and adjacent, and it's tan. So we're going to say tan theta is equal to our opposite, which is 32, over our adjacent is 63. And you should write up here first, tan is equal to opposite over adjacent. So then we're looking for an angle, so theta is equal to tan inverse 32 over 63. So you always have inverse when you're looking for the angle. So you go to your calculator, press shift, press tan, your fraction button, 32 over 63, and that gives you an answer of 26.927678785. The question now, always when you finish the question, look back and see have you answered what you're asked and given it the way they want it. Now, you will get most of your marks for doing that, but you will not get all your marks because it specifically says give your answer in degrees and minutes. Okay? So once you get your answer in your calculator, press the degrees, minutes, seconds button, and it will convert it to the following: 26 degrees, 55 minutes, and 39.64 seconds. Okay, and it says to the nearest minute. Okay, so 39 seconds is more than half a minute, so this is rounded up to 26 degrees and 56 minutes. So you won't get your full marks unless you specifically answer the question exactly the way they asked it. Okay. The next question is on page 316. Okay. So it says the point A is shown on the diagram. Write the coordinates. Again, you always read from the x first. X always comes before y. So x is 1 and y is 4. So the next thing it says plot the points on the diagram. So plot all the points. So plot 2 on the x-axis and 0 on the y is B. C is minus 4 on the x-axis and minus 4 on the y. D is 0 on the x-axis and 4 on the y. E is minus 6 on the x-axis and 0 on the y. And F is 4 on the x-axis and minus 4 on the y. Okay, so that's that part done. The next thing it says is calculate the midpoint of DF. Okay, now it asked you to plot the points. It didn't ask you to actually do anything to join them up as of yet, but you can join them up. Well, you can join up these ones. Put that one out here. Draw it across. Okay. Now it says calculate the midpoint. Again, like I've said multiple times, write down the formula immediately. Okay, so calculate the midpoint of DF. Okay, so I'll call that x1, y1, x2, y2. Okay, and I'll sub into my formula. So 0 plus 4 over 2, 4 plus and minus 4 all over 2. So I've got 4 over 2 and 0 over 2, which gives me 2 and 0. So the midpoint of DF is 2 and 0. Now always go back and see, does your answer make sense? Yeah, oh sorry, it was the midpoint of DF I was looking for, and you can see that B 2 and 0 is the midpoint. Okay, and that makes sense. Okay. The next thing it says is find the slope of BF. Now we know there are two ways of finding the slope. You can use your slope formula, and I'd advise you to write this down regardless of using it or not. y2 minus y1 all over x2 minus x1, or you can use your rise over run. So we're wanting to find the slope of BF. Now we know this line is going down from left to right, so automatically we know it has a negative slope. So you always move from left to right. So I'm going to pick the point B and the point F, and I'm going to see how much am I moving down and how much am I moving right to get to F. So I'm moving down 1. Now don't count the boxes, count the units. 1, 2, 3, 4. So I'm going down 4. Okay, and then I'm running 1, 2. Okay, so minus 4 over 2 simplifies to minus 2. So the slope of that line is minus 2. The next thing it says is write down the equation of the line BF. Okay. Now we know there's two ways of finding the equation of the line, or two formulas. They've specifically asked you to write it in the form y equals mx plus c, so you can use that formula straight away. We know m stands for the slope and c is where the line cuts the y-axis. So we know the slope is minus 2 from the previous part. So y equals minus 2x plus, we look up and see where does the line cross the x or the y-axis, and it crosses the y-axis at 4. So very easy. The equation of the line is minus 2x plus 4. You could use the other formula as well and then just isolate y on the left. Okay, the next thing then is finding the slope of CE. Okay, so let's look at the line CE. So again, you can use the formula, or you can just use rise over run. So I'm going to look at CE and I'm going to see how much, well I know it's going to be negative because it's going down from left to right. So I'm going to see how much am I going down and how much am I going right. So I'm going down 1, 2, 3, 4 units, and I'm running 1, 2. So the slope is minus 4 over 2, again, which is minus 2, just like the other line. Okay, so if the slopes are the same, it means these two lines are parallel. Okay, so again, I would just write down the formula. Just in case you've done something wrong, at least you get marks for writing the formula. The next thing it says is write the equation of the line CE in the form ax plus by plus c equals 0. So it wants you using the other formula. Okay, so it wants to know that you can use both. So the other formula for the equation of a line is y minus y1 equals m by x minus x1. So what you need to use this formula, you need the slope. We know the slope of CE is minus 2. And we need a point on the line. You can pick any point you want. I'm going to pick just this one here, which is minus 6 and 0. And that's subbed in for x1, y1. So y minus y1 is equal to m bracket x minus x1. The next one is a minus 6. So just to simplify it, we know a minus by a minus is a plus. We'll multiply out the brackets, so y minus 0 is just y, minus 2x minus 12. Bring everything to the left-hand side because it says here it wants the equation equal 0. So minus 2x comes over and it becomes a plus 2x. The y is already on the left-hand side. The minus 12 comes over and becomes a plus 12. And we have it in the right format now. Okay. The next thing then is, what is the ratio of the area of triangle BCE to the area of the triangle BCF? So BCE is this triangle and BCF is this triangle. So we want to find the ratio of their sides. Now there are several different formulas that you can use to find the R for the area of a triangle. The one that you probably would have come across first is half the base times the height. You need to know the length of the base and the perpendicular height. And we know that in these triangles. So the length of the base of this triangle is 8 units, and the perpendicular height is 4 units. So all we have to say is half the base times height. Similarly here, the length of the base is 8 units, and the perpendicular height is 4. Okay, so we're just going to write that in here. Half 8 times 4. So half our base times height. I should write my formula first. So that's half of 32, which gives me 16 units squared. The same for this one. Okay, so the sides are the same length, so the ratio is, the triangles have the same area, so the ratio of their areas is 1:1. Okay, the last part here says, state whether the two triangles in part H above are congruent. Now, just a few questions ago we came across similar. I've told you before these come up a lot. Similar is when they are equiangular. Congruent means identical. Right, so the answer is yes. And our reason is they are identical because if we look at the shape, we know that ECFB is a parallelogram. So the diagonal divides the parallelogram, so this diagonal line, into two congruent triangles. Okay, so they're identical as the diagonal divides the parallelogram into two congruent triangles. Now we know there are 4 ways of proving congruency: side, 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 angle, angle, and right angle, hypotenuse, and other side. So you can look at those two and you could do that. So you could find the lengths. Well, you know them. So you know the length of this side here. Okay. You know the length, you could find the length of these by using your distance formula and the length of this. Okay, and the same with the other. And if you found all 3 sides are equal, they are congruent. Okay, so I can let you do that yourselves. So, and that's just using the distance formula. The next one is page 318.